find the GCF for algebraic expressions. So GCF is the greatest common factor, which is the largest number that can evenly divide into multiple terms, or you can think of it as multiplying to make terms. So we need to find the largest term that all those terms can be divided by. For numbers, you use your multiplication facts. For exponents, you can use the smallest exponent that they give you. So the question says, find the GCF for the list, and we have two terms, -6 x squared and 14x to the third. So these are our two terms, and we have to find the largest number that can divide. So the first method is, if you know your facts, then you know 6 can divide by 2, and you know that 14 can divide by 2. So 2 is the largest number that can divide both of those. 6 would actually be 2 times -3, or -6 would be 2 times -3, and then 14 would be 2 times 7. So there's your number. GCF is 2. For the variables, we have x squared and x to the third. So you take the smallest exponent, which in this case is x squared. So x squared is there, and x to the third is x squared times x. So that's where that comes from. So your GCF is 2x squared. That's how you'd find the GCF. So the second method of doing this is if you don't know your multiplication facts and you actually have to break down the terms. So it's the same problem. So now what we're going to do is we're going to take -6 and we're going to break it down into multiples. So prime factorization. -6 is -1 times 2 times 3. And then x squared is x times x. We have two x's there. For 14, x to the third. 14 I can write as 2 times 7. Those are both simplified. I cannot divide any of those further. And x to the third is x times x times x. So your GCF, once you break these down, is literally identifying the common factors in both. So there's a 2 here. There's also an x that's common, and there's another x. So your GCF, what's common, is 2 times x. We want the largest, so we're going to multiply all these things together. And that's how we get 2x squared. And that would be your GCF.